Okay, hi ladies. We're going to look at 4.1 part 2, reciprocal functions. Reciprocal functions. So functions that model inverse variation have the form of f of x equals a over x, where x does not equal 0. They belong to a family whose parent is the reciprocal function, where f of x equals 1 over x, where x does not equal 0. Okay, so a vertical asymptote is a vertical boundary line that your function will approach but never touch. So we usually graph that with a dashed line. All right, and then a horizontal asymptote is the same thing but horizontal. Our function will never touch it, and we use a dashed line to graph it, okay? All right, let's talk about parent reciprocal functions here. Okay, the parent function is going to be y equals 1 over x. Okay? All right, we're going to graph this. So we're going to think when we divide by 0, see, it's going to be undefined. So at 0, there's going to be an asymptote here. It's going to be undefined, because you can't divide by 0. All right, we're going to put a dashed line through 0, and we'll talk about the rest of the points. All right. Go back to a pen. Let's check the time here. All right. All right, if x is 1, 1 divided by 1 is 1. So then y would be 1 when x is 1. And then when x gets smaller than 1, all right, see, y is going to increase. Like if I divide by like 0.1, and then it's going to be up high. All right, and then when x is 2, y will be 1 over 2, or a half. And 3, it will be a third. And 4, a fourth. So it will keep getting closer and closer to the x-axis here. So your graph, all right, I'm trying to do this the best I can, so. All right, it's not bad. All right, well, curve down like that, all right, but it will definitely go through the 0.1. Let's talk about negatives. If I divide by -1, 1 divided by -1 would be -1. So at -1, the y value would be -1. All right, and likewise, it's going to go and approach the y-axis there, and then it's going to approach the x-axis here. All right, so this is a good graph of our reciprocal function. All right, let's talk about the domain. The domain are the x values that are on the graph. So all the x values are on the graph except 0. So we're going to write that. I'm trying to get rid of this thing. All right, from -infinity to 0, but not including 0. And then this part starts at 0, but not including 0. So 0's are parentheses, and it's going to go all the way to infinity. Okay, the range. All right, I did the vertical. So notice horizontal, there's also an asymptote. It never touches y equals 0. So we're going to put another horizontal asymptote here. Okay, because it's not touching that. All right, so your range is basically all the y values except 0. So it's basically the exact same thing. So if I got skills, I'm going to copy this. Okay, so the range is the exact same thing. -infinity, 0, union, 0 to infinity. All right, the vertical asymptote. All vertical asymptotes are x equals. So that would be x equals 0. All right, a horizontal line is y equals. So a horizontal asymptote will be y. And our asymptote is at 0. All right. The same techniques used to transform the graph of other functions can be applied to reciprocal functions and all other functions, all right, as when we taught it. So this a here is going to be a stretch, all right? Like if a is 3, then it's going to be stretched by 3, all right? Or a compression if it's less than 1, like a half, all right? If I directly add or subtract to x, it's going to move it left or right. So a minus h is going to go, it always goes the opposite way of the sign. All right, it's going to go right, h units. All right, and then if it's plus h, it's going to go left, h units. All right, k is up and down. That many units, okay? All right, so let's get into some problems here. Graph each reciprocal, identify the transformation, domain and range, horizontal, vertical asymptotes of the graph. All right, so the only difference is this 0.5 is there instead of 1. So 0.5 is less than 1. So that would be a vertical compression. Of 0.5, 1/2. Okay, that's it. That's our only transformation. So normally, all right, I don't like these numbers here, the way that this graph looks. All right, 1's here. So the numbers are above where the line is. So normally at 1, it's at 1, but because it's times a half, it's only going to be at a half. All right, likewise, the negative 1, instead of being at negative 1, it's going to be negative 1/2. All right, it didn't move left or right, so it's going to have the same shape. It's just going to touch this point and then pretty much get closer and closer to the y-axis. All right, and here, it's closer to the y-axis. It touches this point, and then it's going to get closer and closer to the x-axis. All right, they wanted the domain and range. All right, it's going to be the same as the previous one we did, from negative infinity to 0, union, and then 0 to infinity. Okay, and the range, all the y values, everything except 0. So it's the exact same thing. All right, a vertical asymptote will still be at x equals 0. Horizontal asymptote and we will abbreviate these VA and HA, just so you know, often. All right, will be y equals 0. All right, let's move on to a more interesting problem. All right, let's discuss the transformation here. The negative reflects it. All right, so it reflects it over the x-axis. All right, so it's going to be reversed. So instead of going from the top and then down to the right, it's going to start at the bottom. All All right, so it's reflected. The 2, vertical stretch by 2. Okay, it's not moved left or right, but it is moved down 3. All right, so let's start with that, the down 3. So normally, the horizontal asymptote's at 0. So now we're going to move it down 3. Uh-oh. Let's lock this puppy down. Lock in place. All right. So we're going to do a vertical asymptote at -3. And draw that. Okay, the horizontal asymptote is still going to be at 0 because we did not move it left or right. So that's still going to be at 0. All right, so think of like this point right here as like being like your origin. Okay, now the negative, let's grab a pen here. Okay, the negative is going to make it start at the bottom and go up. All right, but the 2 is going to stretch it by 2. So, like when x is 1, -2 divided by 1 is -2. All right, I know it's down 3, but starting at -3, we're going to go down 2 instead of down 1. Got it? All right. And then if we did like 2, so if I go to the right 2 over 2, -2 over 2 is -1. So it's going to be down 1 from the -3. And then here, that'll be 2/3. So it's going to get closer and closer. All right, so it's going to start at the bottom. And look this way. All right, and then this one is also going to be reversed. All right, so we're going to go over 1. It's going to go up 2 from there. And there's going to be 1. And that's going to go up. All right, so we get a general idea here. All right, let's give the domain a range. And the vertical asymptote, we're going to abbreviate, and horizontal asymptote, we're going to abbreviate. Let's start with the horizontal asymptote. That's this one. That's y equals -3. All right, the vertical asymptote is still going to be x equals 0. Okay, the range, it's going to be all the y values except -3. So we're going to go -infinity to -3, union -3 to infinity. Okay, the domain, we're going to go from, it's going to be the same as the previous ones that we did. Uh-oh, I want to erase that. I want -infinity there we go. -infinity to 0, union 0 to infinity. All right? All right, let's see how much time do I have. Okay. All right, I might be at the 15-minute mark here, so I'm going to stop this video here, and we'll cover the rest in class. Okay, ladies? All right, good job. Thank you.